Let's talk more about elements in sets and that notation we can use there. So we use this symbol. It almost looks like an E, but it's curved. It's not quite an E, but it looks a little bit similar. It's used to indicate that an object is an element of a set. So for me, this is very informal, but I almost think of it like the word in, like that item is in the set when I see that symbol. So it replaces the words is an element of. So that's really the formal way that we would say that. This symbol, so I should say is used to indicate that an object is not an element of the set. So it is not in the set. And again, it replaces the words is not an element of. So determine whether each statement is true or false. So what this says here is that R is in the set or is an element of the set here. Now notice these A, B, C all the way up through D. So this dot, 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 when you do it like this, means that there's other elements in between. We're just not going to list them all because you should recognize the pattern. We're going from A, B, C all the way to Z. So these are all alphabet letters that are lowercase, right? Lowercase alphabet. So is lowercase r in the set of the lowercase letters in the alphabet? Yes, it is. So this is true. Here, this says that 7 is not in the set 1, 2, 3, 4, 5. Notice I don't have any dot, dot, dots. It ends at 5. We have all 5 elements here. 7 is definitely not one of those 5 elements. So this is true. 7 is not in this set. All right, the last one. This one's tricky. So again, this symbol here means is in the set. Now, most people would say that it is true, right? Well, yeah, A is in the set. I can see that. That's not A, though. If I wrote A is an element of the set A and B, oops, this is true. A is right there in the set. This is saying that this, the set of A, is in the set. So if that were the case, it would have to look like this. Okay, so if this is in the set, the whole piece here has to be in the set. So this says the set of A is in the set of A and B. So this is true. This is not true, right? Because that symbol is not in there, just the A is. So this is where it gets really tricky. You have to be really careful to see if that exact element is in the set. Because this is not just A, because that's just a plain A there. It's not in the set. This is the set of A, and it's missing the extra set symbols. So it's not an element. Okay, let's do a couple more examples with sets and elements. So there's lots of famous sets, but one very famous set and one that you've seen before, I'm sure, is a set of natural numbers, and maybe you just haven't thought of it formally this way. So your natural numbers are your counting numbers. They're what you learn when you're little, right? And it starts with the number 1. And they're whole numbers. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. forever. So it's all your whole numbers, but not 0. We start at the number 1. Those are called your natural or your counting numbers. And we write the set like this. Okay, so this is like roster notation. When we're typing, we use a bold N to show the natural numbers. And notice here that you have that dot, dot, dot on the end, which means that that's going to continue on indefinitely. There's no ending number afterwards like we saw in the other example, so it's going to just keep going forever. When we're writing the natural numbers, it's hard to write in bold, right? So usually what you'll see is something like this. So you'll see like an N, but you'll see an extra line on it here. So that kind of makes it look a little bit more bold. So handwriting, when you see me write, I will write the set of natural numbers in that notation instead of bolding when I'm writing by hand. Express each of the following sets using the roster method. So A is the set of natural numbers less than 5. Okay, so these are my natural numbers, and I only want the ones that are less than 5. I'm using the roster method, so I'm going to physically list those elements out. So number 1, 2, 3, and 4, those are all my elements less than 5. Set B is a set of natural numbers greater than or equal to, so it could be equal to 25. So I notice I start the same way. I always start with those little squiggles. Now, greater than or equal to 25, so it could be 25. And again, it's natural numbers, so we're just doing whole numbers here, no fractions or decimals. 26, 27, 28, 29. Now, I can't physically list every number, right? It's going to keep going forever. So what we do is we do a dot, dot, dot at the end and write our brace. And that shows, I've shown enough elements to show the pattern, right? You do need enough elements to show the pattern. And then you can write dot, 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 and it's assumed that that keeps going. Here, E is the set, and it's all x's such that x is in the natural numbers. So this right here means that x is in the natural numbers. Okay, so it's either 1, 2, 3, 4, 5, or so on. And it's even. So my even natural numbers are 2, 4, 6, 8, 10. And again, it's going to keep going. So I'm going to use a dot, dot, dot after I've shown enough of the pattern so that we know that it keeps continuing. Now, I did assume here that you already understand things like less than or greater than. If you need more examples, I do recommend you go through page 55 in your text. There's a nice chart there that goes through a whole bunch of different examples of less thans and greater thans and so on. So you can check that out. I'll just do a quick review here, but again, check out page 55 for more details. So for instance, this symbol here is used for less than. And this symbol is used for less than or equal to. And then you have this symbol is used for greater than, and then this symbol for greater than or equal to. So remember, if you see less than or greater than, we're not including those end values, right? You're going strictly smaller or strictly bigger. Whereas if we see less than or equal to, greater than or equal to, we are including that ending value, right? So it is included as part of our answer there. And you can even have numbers on either side. So for instance, if I was looking at numbers, let's say, and I want all x's such that x is a natural number, and maybe I wrote something like x is less than 9, then again, I can express this as the set 1, 2, 3, 4, 5, 6, 7, 8. And because I'm strictly less than, I'm not going to include 9 in my set. I have to be strictly smaller. We could have another example of x such that x is in the natural number, so it's some sort of natural number. And maybe I have something on double-sided. Maybe I have that 4 is less than or equal to x is less than 8. So in roster notation, I'm including 4 because I have that equal sign. So I have 4, 5, 6, 7, and then I have to be careful. I'm strictly less than 8. So we're saying that x is between 4 and 8, but 4 is included because I have equality here, and 8 is not. So this would be my set. And again, if you check out that page in your text, there's 1, 2, 3, 4, 5, 6, 7, 8 examples. So here I just did 2 quick ones, but check out your text if you need some more work with those inequalities before moving on. So let's do these 2 examples. Express each of the following sets using roster method. So we're going to list out the elements. So x such that x is a natural number and x is less than or equal to 100. So what we can list here, now your natural numbers start at 1, and we're going less than or equal to 100. So my first natural number would be 1, and then 2, and then 3, and then 4. Now it's too much to list every single number from 1 to 100, right? So once I've shown a pattern, I'm counting by, ones here, then I can use dot, 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 and then write my ending value. Sometimes people will write a couple numbers. They may write like 99, then 100, but you don't have to. You can just write the ending value. Because you have equality, that 100 is included. So this is my set. In this case here, same idea. So x, such that x is a natural number, and x is between 70 and 100. But we see that we have equality on 70, so 70 is included, and we're strictly less than 100. So you have to be smaller than 100 here. So we're starting at 70, 71, 72, 73. And again, I'm showing the pattern, and then I'm going to show how it ends. And in this case, again, we're not going to 100, we have to be strictly less than. So the next highest number is 90. And again, that's sufficient. Sometimes you may see a couple values on the end, like if you wanted to, you could write 97, 98, 99, which is fine too. But traditionally, we just use that one ending value, assuming that the pattern has been clearly shown.